We know how to calculate the derivative of inverse trig functions. What I'm going to do here is I'm going to present you with a couple of examples. I want you to read them, pause the video, have a crack at them, and then come back and check your answers with the working presented. Here you go. So just two questions for you. First, I want you to differentiate ln of 1 plus cos minus 1x. And the second one, slightly trickier, I want you to find the derivative of tan minus 1 of 1 plus sin x over 1 minus cos x. So pause the video and have a crack at them. So the first one was differentiate ln of 1 plus cos minus 1x. Now the easiest way to do this is to use a substitution. So I would do ln of u, and what I'd say is I'd let u equal 1 plus cos minus 1 of x. Because then what I know is that derivative dy by dx is equal to dy by du times du by dx. And all I'd have to do when I calculate dy by du is substitute back in. So if y is equal to ln u, then dy by du is equal to 1 over u. And if u is equal to 1 plus cos minus 1 of x, du by dx is quite simply equal to, well, the 1 differentiates to nothing. Cos minus 1 of x we know is equal to negative 1 over square root of 1 minus x squared. We know that previously from the video. So now all I have to do is combine these together. What I'm also going to do is substitute this back in for the u here. So what I can say is dy by dx is equal to 1 over 1 plus cos minus 1x times the du by dx times negative 1 over square root of 1 minus x squared. Simplify the whole thing and stick it together in one fraction. What we'll end up getting is negative 1 over the 1 plus cos minus 1x in a bracket times the square root of 1 minus x squared. So there you go, a nice simple looking derivative. Yeah, slightly trickier than you would have thought originally, but actually not too bad when you follow the steps. It just looks a heck of a lot more complex than you'd expect. The second question was to find the derivative of tan minus 1 of 1 plus sin x over 1 minus cos x. Now this kind of question does look quite complex, so what we need to do is break it down into parts, do each part separately and bring it back together so that we're able to do it in a much easier fashion. So if I let this be y equals tan minus 1 of u, and what I'm going to do is set u equal to this part in the bracket here, so the 1 plus sin x over 1 minus cos x, what I then know is that dy by dx is equal to dy by du times du by dx. So all I do now is I get my two separate parts, dy by du, so derivative of this, times du by dx, so derivative of this part, and multiply them together. So let's focus on each one in turn. So dy by du, I know y is equal to tan minus 1 of u, so dy by du for this one, I know is going to equal 1 over 1 plus u squared. Now I'm going to substitute back in for u, which is this part here, so that's going to equal 1 over 1 plus sin x over 1 minus cos x all squared. Now that there looks like a fun fraction to work with, so what I'm going to do is try and simplify this before I move on. Now if I focus here on the bottom, this here is the equivalent of splitting it off and doing a square bracket on each bit. So all I'll do is just focus on this part now. So I've got 1 plus bracket 1 plus sin x all squared over 1 minus cos x all squared. What I'm going to do to turn it into a single fraction is put it all over a common denominator of 1 minus cos x all squared. So what I end up getting is 1 minus cos x all squared plus bracket 1 plus sin x all squared, all divided by 1 minus cos x all squared. Now if we go back to dy by du, we know it's going to be 1 over this, so it's 1 divided by that. So in order to get that, we flip the fraction round, and what I'm able to say then is that part, what would have been the dy by du, that's equal to 1 minus cos x squared over bracket 1 minus cos x squared plus the 1 plus sin x squared. So there's the first part there. Oof, that's a fun looking fraction. The second part that I need to do is find the derivative of u with respect to x. So what I want to do now is do du by dx. Now I know it's 1 plus sin x over 1 minus cos x, so what I want to do is use the quotient rule. So derivative of the top times the bottom, take away derivative of the bottom times the top, all over the bottom squared. So derivative of the top is just going to be cos, so it's going to be cos x bracket 1 minus cos x. It's then going to be take away the derivative of the bottom, so 1 goes to nothing, cos x goes to minus sine, so that's minus minus sine, which just becomes sin x bracket 1 plus sin x there as well. That's then all over 1 plus cos x all squared. So I've got the base part of it, now I need to simplify as much as I can. So if I look at the top here, what I'm going to get for the top, if I multiply out both brackets, is I'm going to get cos x minus cos squared x minus sin x minus sin squared x. If I gather all this together, I'll get cos x minus sin x. I've got cos squared and sin squared. Well, I know cos squared plus sin squared is 1. But if I take out the common factor of negative 1 here, I end up getting negative 1 bracket cos squared plus sin squared. So that will become 1. So for this, I can simplify it down and write it as cos x minus sin x minus 1 all over the 1 minus cos x all squared. So now that I've got the two parts, what I do is I combine them using the rule here and I get my full derivative. So from that, I know that dy by dx is going to equal my dy by du, so this part here. So I've got 1 minus cos x all squared over the 1 minus cos x squared plus bracket 1 plus sin x squared. That's then going to multiply this, so it's going to multiply cos x minus sin x minus 1 all over the 1 minus cos x all squared. So we need to stick it all together and simplify as much as we can. Well, the 1 minus cos x squared goes from both of these, so when I put it all together, I get cos x minus sin x minus 1 is the numerator, and my denominator is 1 minus cos x all squared plus bracket 1 plus sin x all squared as well. So there you go, that's my dy by dx. Or at least that might be what it seems like at this stage. If you look at the denominator, this doesn't exactly look the most simple of formats. So what to do is multiply out all the brackets, gather everything together and simplify it. And if I were to do that, my numerator would stay the same. So cos x minus sin x minus 1. But my denominator, once I've got everything together, simplified it and factorized it, would be minus 2 bracket cos x minus sin x minus 1. Look at that. It's the same as the top except with a negative 2 out in front, which we've taken as a common factor. So because of that, all we can do is cancel this cos x minus sin x minus 1 part here, and lo and behold, all of this working through this entire derivative eventually gets me to an answer of -1/2. So I've done all of that work to get down to -1/2. Seems like a bit of a scunner and a bit more fun than it should be, but sometimes at advanced higher, this is the level of work and level of commitment to a question we need to show. We need to be able to work our way through, bring trig identities that we've covered every single year up to this point, and the basic premise of things like multiplying out brackets, simplification, common factors, etc. Apply it to this sort of thing so we can take something that looks like this and realise that actually when I whittle it down, I get to something nice and easy like -1/2. That's the fun we've got to look forward to throughout the rest of the course.